All right. Hello, everybody. First of all, I was not expecting a 360-degree view of my butt, so I'm happy to be up here looked at from all angles. This talk is about how to leak resources in JavaScript. It's not as scary as he said. A lot of people left after he said that. It's a little scary. Let's see if this thing's working. There we go. That's me. I'm Ben Lesh. I'm the RxJS guy. I've been maintaining this library called RxJS for 7 years, something like that. It's a very popular library. It gets downloaded an awful lot, about 41 million times a week. If you use anything like Slack or YouTube or Netflix or PlayStation, you've probably used something that uses RxJS somewhere in that stack. If you examine your node modules, it's probably in there from some other dependency. Come on, please. Yes. All right. So RxJS is basically Lodash for async. Now, I have a weird order of business here, which is that there is a RxJS core team member here who I've never met in person. Mlad, there he is. So I've seen him in person. Hi, Mlad. How are you? Great. The first time I've ever seen this guy in person. So if you have any RxJS questions, ask him. You don't need to ask me anymore. All right. So this clicker, there we go. What is async? So I'm talking about leaking memory with async code, and it's worth mentioning what async is. A lot of people think they understand it. There's different ways to define it. I want to define it more clearly here. Async code, I have to click this twice every time? Just point it that way? There we go. If you look at the definition on Google, it says a bunch of nonsense like not existing or occurring at the same time. Let's see, controlling the timing operations by the use of pulses sent when there's no pulses in JavaScript, I hate to tell you. So none of this is terribly accurate. What we're actually talking about here is, come on, there we go. Different events on the event loop, all right? That's what async is in JavaScript, effectively. Now, I'm going to talk about what the event loop is very loosely. I'm not going to dive into deep particulars of it and microtasks and all these things. Effectively, what it is this queue that processes events one at a time. Everything that executes in JavaScript executes as an event, a standalone thing. It goes into a stack, it processes them one at a time in a single thread, and there's this loop that just pulls them off and executes. It has no context to what the previous event is or anything like that. So that's what the event loop is. So if something's asynchronous from something else, it's because it occurs in two different events on the event loop, roughly speaking. Now, there's other ways to define that, but that's how I'm defining it for this talk. Now, completely synchronous code will be a single event. So everything I've highlighted in yellow up here, when you call this function, this do something sync function, all of that is going to get put as a single event in this event loop, as generic as I've made it here. Where if you're dealing with async code, and here I've got a promise, right? So you have to wait for the promise to resolve, and it executes the then block or whatever. It executes the body of the function, and that's one event on the event loop. And then there's another event put on the event loop when that promise resolves to execute the body of that then block. There's a lot more that goes on, but this is a rough concept for you. All right. So why is this hard? What I just showed you there wasn't terribly easy, or terribly hard, rather. It was pretty easy, simple code that I just showed. But why is async programming hard? Why would it cause leaks? Come on. There we go. Now, asynchrony adds unknowns. So I'm looking back at my do something sync code, and it's still going to do something totally synchronous. And I've got a function call in there. Now, I live in a world where you can do asynchronous things inside of functions, right? And still return something synchronously. A function always returns something synchronously. So what would happen if I click this several times, and what would happen if getValue actually started something asynchronous? You don't know that from this code. You see, no one's going to write hopefully nobody's going to write a function that does that, but you don't know that. And this is just a small illustration of why asynchrony is hard, because you were looking at this code before, and you were reading it top to bottom, left to right, and you thought you understood it, or exactly what it was going to do. Just like I think I'm going to understand this clicker. There we go. All right. So asynchrony adds another dimension to readability problems. If you're looking at your code, there, Code flow, when you're looking at your code, it reads left to right, top to bottom. So you're looking at this code, you know exactly what it's going to do and when it's going to do it, roughly speaking, with the exception of this is asynchronous code. So you're looking at it top to bottom, left to right, and there's a block in the middle that's doing something at a different time. Right? Get value, it goes off, and it does, we don't even know what, right? It's getting a value. It could be getting a value from some web endpoint. It could be getting a value from some user input. It could be getting a value by literally emailing a guy named Bob who's going to respond to that later, get processed, and come back to your JavaScript. You could implement that. It would be weird, but you could do it. But there's no guarantee what's going to happen. You could go out into a network, and the network could die. You could go to a server, and the server room's on fire. You don't know what's going to happen. And it's because it's like a side quest, right? You're reading through your code, and then all of a sudden it jumps off to the nether, and you don't know really what's going to happen. That's why asynchrony is hard to reason about. Come on. All right. So let's talk about resources then. What sort of resources can we leak? The sorts of resources are things like memory, CPU, and other things, usually I/O. So memory would be leaked through things like references to things, DOM elements, objects, function references, that sort of thing. CPU gets leaked by processing code. A leak to that sort of thing means you're executing code you didn't even want to. You're calculating something you're not even going to use, right? That's not great. Or you're parsing some JSON blob that you're just going to throw out right afterwards because you don't care, right? And then other would be if you happen to leave open a file handle or leave open a network connection or something that you no longer care about because you've said, I don't care about this anymore, but there's still code dealing with it. So again, just those are the sorts of things you can leak. Memory, CPU, I/O, other things. And all of this can be done with bad asynchronous code especially. Why is leaking resources bad? I think some of us have some idea like, oh, leaking resources is bad because, I don't want to use a CPU or whatever. I mean, come on, clicker. There we go. Global warming, basically using a lot of electricity. No, it's not really that bad. Bad code is basically destroying the world. No, it's not that bad. But it is bad. You don't want bad experiences for people, right? You don't want people's low-end browsers, their low-end phones, getting warm in their hands because you're executing a bunch of code you didn't need to. So let's start talking about this. Let's look at some nice, simple asynchronous codes. Here we've got a function called getUserList, and it takes an optional filter. And in here we're calling a getAllUsers, and then we're filtering it down. Now, maybe a better thing would be to have an endpoint that actually took the filter and returned just those things, but this is what we were provided from our backend developer. And so we're saying get all users and then filter the users maybe or otherwise don't, and we want to get the user list, just a list of names. So very, very simple code. And then, this is with the then statement, such an old way to do it. So the tech lead on your team is like, well, actually, async await is the way to do this, man, because it makes everything so much more readable. So great, you convert it to async await. Now we've got async function, a little await in there. It's the same basic concept. Easy peasy, very simple code, very easy to read, top to bottom, left to right. And await made it even better because now it really does read like a synchronous function, right? But it's not really. It's still doing something asynchronous. So sorry about the clicker, guys. Come on, there we go. All right. Now you wire it into some UI. So I'm using React here. Framework's your choice. I just picked React because it's the most common one. It's what I work with regularly at work. So we've got it to where we've got a couple pieces of state. We wire in our use effect, right? And so when someone changes it, blah, 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 this isn't a great way to do this either, but we've all seen this pattern before. This is a very common way to develop a React app. Great. I love the, I should just start clicking it in advance while I'm still talking. All right. So you get new requirements from the business office. Everyone loves a busy project manager. Project manager is like, hey, we want that list sorted by purchase count. You're like, all right. So you pair up with your backend developer. The backend developer gives you some other horrible endpoint to hit. And I click this. There we go. I click it too many times. Come on. This is async clicking, by the way. I'm doing this is very asynchronous. All right. Yeah. So you add in this additional, so we've got another await here. Like partway down, you see with this await, get purchase counts by users, and we're mixing in. So we've got 2 awaits in this function. Great. No problem, no sweat. Feature implemented. We update our UI, and boom, everything works awesome. And then we start getting bug reports in. We actually get 2 bug reports. First bug report comes from that back-end senior engineer guy that really doesn't like front-end web developers. And he says, you're spamming the server, stupid front-end devs. Every single time someone types this, they're sending a bunch of requests to my servers, and you're ruining his day. Okay, so that's one Jira. Next one that comes in is they get stale searches sometimes. This comes from Bob in accounting. He can't really explain what's happening. He just knows that sometimes he sees stuff there that he doesn't think should be there. Stale searches is what he says. All right, so you think you have a good idea of what this could be. They're probably both related. So you're like, all right, a quick Lodash debounce later, you add your Lodash debounce in, and then that doesn't work because it's React, and you're like, all right, hold on, a quick search to figure out how to make Lodash debounce work with React. And then you're like, forget it, I'll just implement it myself. It's just a set timeout. And so you add this, and I've got like I got a ref here, get my debounce ref. I've got a timeout in there, clear timeout. Like I added my own debounce because I'm an async wizard, right? I work on an async Lodash library, so no sweat. All right, so both Jira's closed. You can't reproduce Bob's problem anymore because you could before, but now it seems to have gone away. And backend guy is no longer complaining at you. But here comes Bob from accounting again. Bob is reopening Jira app 1022, and he's like, look, I still get these stale searches. Are you sure you know what you're doing? Like, I still get these stale searches sometimes. And you're like, okay. So now you're desperate. Now you're like, I don't really know what's going on. So you're going to go check the logs. Hopefully you have logging. So you check the logs, and you got this gobbledygook logs here, and you're looking through, and you're like, okay, here's all the requests coming into the back end. And then you notice something. Wait a second. The first request that I made to get all users responded after the second request. So Bob was typing, and it got past the debounce, and it made this two requests to get all users, but for some reason the back end responded slower on the first one. And you're like, what the hell? Okay, all right, I'm gonna talk to the back end guy. The back end guy, you're like, hey, this looks like a back-end issue. Do you think you can fix this? Like, why is it responding out of order? And then the senior developer, being, just superior intellect, is like, well, actually, you should know that distributed systems are like blow, and you tune them out after a while. You don't read the whole thing. You're like, all right, so he's not going to help me. But what's happening is effectively one of the services it's routing. It's going to the other side of the world sometimes, and sometimes it's very local, and so things come back out of order. That's the explanation. So it is your problem. You do have to solve it. So here's what you end up having to do. You end up needing to check something after every single await in here. When I look at a lot of async code, and when I look at an async function and I see an await, I look right after it to see if anyone's checking a Boolean or an integer or anything to see if they should stop the execution of this async function. Always look. And you know the percentage of the time I actually see that? I would say maybe about 10%. I would bet, and maybe I'm wrong, maybe Croatians are superior in every single way, but I would bet if all of you went home and you looked through, or you probably don't take your work home, hopefully too much, but if you went back to the office or went home or whatever, and you looked through your code base and you looked at your awaits, you're going to find that a lot of them are lacking this check. But this is what we need to do, because we need to know, like, oh, I didn't care about this result. I need to stop. And then we go through and we have to thread this whole thing through. We're like, okay, so now in my use effect, I've got this token, and it has to be a reference because I need to be able to pass it into another function and check it. So it's got to be an object with a canceled, property on it. So I make this token, and I return my teardown for my use effect, and it's going to flip that canceled bit to true when it tears down. So if you're anywhere inside of that function, inside that async function, it'll know I need to stop now. This is getting kind of advanced already, right? Like this is not like, oh, junior developer, 101, I'm going to go do this today. This requires a little bit of expertise. And as you noticed, there's nothing really provided by JavaScript or a framework or anything to let us do this. We had to kind of manually roll it. So the question becomes, like, if you're staying on the paved road, you're doing what your tech lead says, you're making something with async await, you're doing the easiest thing possible. Why is it that you can end up in these situations where you're leaking resources and executing code because here's the thing, that's stuff's going out there, it's coming back, JSON's being parsed, code's being executed, views are being updated to what you didn't want them to be updated to. You want to stop those things. Why is it so easy? I mean, we fixed it, but again, it's still leaking resources, actually. Like, we only solved the view not updating problem right? So if we look at this, right here, we still have to hold on to the object token until get all users is resolved. Everything in memory in an async function, by the way, stays in memory for the duration of the entire async function. You create a huge object up here, and you add a for loop down here with awaits in it, that huge object's in memory forever. It's at least until the async function clears up, because it's in scope. We've got the same problem here. You have to wait until the get purchase counts by usernames, that's a typo, but get purchase counts by users resolves to clean up the token down there. And at this point, we've also been retaining the users array the entire time. But it gets more fun than that. Actually, if we're doing this at all, even though this is the thing to do, by the time you get to where you can check token canceled, you've already hydrated that user object, right? The user's object. You've got this whole array in memory. You've allocated allocated a whole bunch of objects. You've parsed JSON. You've executed a lot of code. And for what? Now you've got a garbage collected. Guess where garbage collection happens? Same thread. So the garbage collection actually happens in the same thread as the rest of your UI that's running. So you might end up even seeing a little jank from that if it's a big enough array. Same problem down here. By the time we check it, purchase counts and users have already been entered memory and now need to be garbage collected, right? We also need to check that token here, if you haven't noticed. Even though we've already done all this async work, the reason we need to check it here is because elsewhere in our async function where we were doing, hey, if this is canceled, return, now this then is going to get called with undefined. And we don't want to set results to undefined. We want to just leave it. So we need to make sure we jump out of that here as well. Because it's complicated. And it's complicated to solve a very, very common problem. All right, some of you might say, but Ben, fetch, if you just use fetch, it's got a abort signal now. That solves this problem. It means you can cancel your actual HTTP request. Maybe it won't parse all that JSON and so on and so forth. That's right. You're going to save some of that. However, you're still executing code you didn't want to. And I put this here to illustrate it, where that comment is. It says, never mind, I knew I canceled this. Now you're in this async function, and what happens when you abort fetch is it will throw. And you have to put a catch there and check to see if it's an abort error. Because promises must resolve or reject. You can't just leave them hanging out. If you left them hanging out, this whole thing would never, ever resolve. And it would all just hang out in memory. Everything would hang out in memory for a long time. You've leaked resources anyways, right? So it has to reject, and it rejects with this abort error, which you have to check. You're executing code to check that. You can see it's not perfect. All right. So again, I think we now understand why this is so easy to mess up, but let's drill it home. It's easy to mess up because it's a byproduct of the tools we have available. I mean, plain and simple, we're missing the good tools that we need in order to accomplish this sort of thing. And I'm actually not here to sell you RxJS, by the way. I'm the RxJS guy, and I'm not going to get up here and be like, yeah, just use operators. And I've seen people do horrible stuff with that. I'm not even talking about that. I'm talking about what we have available in the dire situation that it is. So available tools in JavaScript in 2014. you've got this chart here, and on the top row we've got if you only want one value. The bottom row is if you want 0 to many values. And then we've got synchronous and asynchronous. So we can kind of bust things out like this. So if you want a synchronous single value, you can use a variable. You can use a function return, because functions have to return one thing synchronously, right? You can use a getter. Same kind of idea as a function return. For async, the only thing you could do is callbacks. You had to pass a callback to a function. So this is 2014. And then for synchronous, if you're dealing with many values, you had a lot of different choices. Iterables, all of these are basically different flavors of iterables. Actually, in 2014, we didn't have sets and maps, or generators. That's my fault. Those shouldn't be there. But you had iterables and arrays, basically. But what they discovered way back then is that, wait a second, callbacks work for all of these things. And people started writing APIs that used callbacks for everything. And people would get confused about whether or not the callback was going to be called synchronously or asynchronously. They started to depend on the synchronous case. Sometimes bugs were created. So they're like, aha, 2015, let's add promises. Promises are going to solve this. Promises are great. I just spent a while trashing on them. They're great for dealing with a single async value that you promise will show up or reject. It has to do to one of those two things. That doesn't cover a whole ton of use cases for us. It doesn't cover cancellation, right? And then in 2017, you had async await, just more promises, really. Then 2018, they added async iterables. So async iterables handle this many value case of dealing with something asynchronous, many values, 0 to many values. And async iterable is actually an iterator of promise, of iteration results. Right? So a promise of an iteration result, it's just an iterator of those promises, right? So promises are still involved in this. And again, promises are not cancelable. So, but you look at this chart and it seems like we've covered everything. So why am I saying that tools are inadequate? I want to talk really quickly about some basic async concepts. This is truth. Async 101, there's a producer and there's a consumer. Now, a producer is the thing that's producing values for you asynchronously. It might produce one, it might produce none, it might produce many, right? And it's got to be able to tell you when it's done or whatever. So, but the important bit is the producer is the thing that's producing values for you. Maybe it's a WebSocket connection, maybe it's mouse clicks or something. The consumer is the code that requested the value from the producer. These are just conceptual things. And when you're talking about asynchronous code, these are very helpful conceptual things. So the code that says, hey, start listening for clicks. The code that says, hey, open that WebSocket. That's the consumer. And then the producer is basically doing something at the behest of the consumer to make sure the consumer gets the values they care about. Now, the other thing that you need to know about asynchronous code, this is again 101, all async has an outcome. And there's only about 7 of them. There's only 7 possible outcomes for async code. See, outcome number 1. Producer sends 1 or more values, and then says, I'm done without error, right? So here's your values, here's 1 value, I'm done without error. The producer sends no values and has an error. So it doesn't send anything. It's like, I had a problem. Sorry, I can't send you values. The producer sends no values and is done without error. It says, hey, I don't have any values for you. Sorry, but there was no errors at least. I'm done. The producer sends 1 or more values and then has an error. So here's a couple values, and then, oops, there's an error. This is getting kind of derivative, right? And here's the one that bit us before. The consumer no longer needs the producer to send it any values. So this is a way that async can come to an end. This is an outcome. This is the consumer saying, I don't care anymore. Stop it. Close that WebSocket. Get rid of that event listener, whatever you're doing. And then the final one is the producer never sends a value, never tells you that it's complete or it's done, never has an error. It's basically like new promise, and then you don't do anything on the inside, right? Like it just sits there and hangs out forever. That's just a leak. You don't want to do that one. That one's pretty bad. And then this is derivative of that other one too. It sends 1 or more values and then never ever tells you that it's done. It just stays open forever. This one actually does happen. Sometimes you have a WebSocket you want to keep open. You want to keep open for the duration of your app, whatever. So promise only covers about 2.5 of these. It can send 1 value and tell you it's done without error. That's then, right? It can send no values and tell you it has an error. That's catch, or the second argument to then. Or you can just create a leak and say new promise and never do anything with it, never have it resolved, never have it rejected, just hangs out in limbo forever. Those are the only situations it covers. It doesn't cover any of the rest. Cancellation in particular, again, is a glaring issue. Now, we get async iterables. It covers more of these, right? You can send zero to many values. You can communicate when you're done, because it has a little bit in each one of those things. It tells you when it's done. You can communicate that it's done, it doesn't have an error. So it basically covers a lot more of these scenarios. It's very close to what we need, but you see the cancellation bit's still missing. Now, you can cancel async iteration by simply no longer iterating. Like you can do a for await loop and put a break in there or something. If you never call next to get another promise, clearly you're done, right? If you've got an async generator, you can call return on it and have it hit the finally block inside there and tear things down. So there's ways, but it's still not really cancelable because it's built on promises, and promises cannot be canceled. All promises must settle. So again, anything built on promises can never truly be canceled. We've built our entire infrastructure for JavaScript on promises. And I just want to stress this again. Promises will never be cancelable. There's been proposals that have come up that get shot down. They cannot and will not be cancelable. They must resolve or reject. So as long as you're using promises, you're probably leaking resources in some cases. Pretty damning, I'm sorry. There's big promise fans here that are probably like, Ben's such a jerk. All right, sanity check. It's probably okay. All right? Like if you go back and you look at your code and you're missing the little Boolean checks or whatever, I mean, honestly, if people are using your app, it performs well, it's probably like 1 in a million that they're going to have a problem in some of these scenarios. It's probably okay. It's not always okay. And if you want your code to actually be perfect or not leak resources, then I've shown you what you need to do, at least in some cases, or at least help. But what else is out there? I'm sorry, I'm going to go over time, this Flickr business. Observable, of course. That's the library that I work on is built on observables. But I'm still not trying to sell you RxJS as observable. I just want to talk really quickly about what an observable is. An observable is, well, how many people here work with React have seen something like this before? No, there's only one person that works at React. That's awesome. I'm going to tell my friends at Facebook that they quit. Okay, good. So we got a few. It's waning. Quick is winning, I think. So we got this use state, use effect, whatever. If you've seen something like this, and maybe you put it inside your own custom hook, right? What you've actually done when you do this is you've created, wait. You also can't forget error handling, so you got to add something in there. We've got a bit for setting state for the error. What you're actually doing inside of here is you've made a weird React-only observable. That's exactly like this shape shows up all over the place. If you wrote an observable, this type, it would look like this. You've got new observable, it gives you a subscriber. You create your resource. You return a function that tears the resource down when you're done with it. And then you set up your events to push things through that subscriber. And then anyone that subscribes to this observable, they'll execute the body of that, set up the resources, get things pushed out. I'm not going to dive deep into how this works. I just want you to know about it and look at it. So observables are a primitive, like a promise. They're actually so primitive you can write promises from observables. You can't go the other way around. They handle 0 to n values. They handle the setup of event resources. They handle the teardown of event resources. They provide a clean API for cancellation. So you get a subscription back, you can unsubscribe from it. It tears everything down automatically. And they're basically fancy functions with a lot of safety features. They guarantee that teardown is going to be called, whether it completes or errors or somebody else calls the teardown, so it helps you prevent you from leaking those resources. And observables are all over the place. These libraries listed here, React Router, XState, MobX, Relay, Recoil, GraphQL, or PolyGraphQL, Redux, ViewSvelte, RxJS, they all have observable implementations in them. They look a little different, but at the end of the day, they are a primitive type called an observable. They've just reinvented it. So what would happen if we actually had observable built into JavaScript? None of these libraries, that whole list of libraries there, would have to implement it anymore. I wouldn't have to implement it anymore. I could walk away from RxJS a happy man. I don't have to deal with the world's most popular implementation of observable anymore. Oh, come on. There we go. There's a 7-year-old proposal right now in the TC39 languishing there. It hasn't been rejected. It's just sitting there, no champion, for observable. The same type that RxJS is built upon was modeled after this proposal when the proposal was first made. But man, I don't like RxJS. I don't want to bring it in. Like, I get it. That's fine. I've seen what people do with RxJS sometimes. It's horrifying. And you don't want to pull in all of RxJS just to get observable out of it either. Like I'm telling you, you don't need to use operators. Just use observable, at least if you want cancellation or you want 0 to many values. So what we want to do in RxJS, come on, man. There. And again, I just want to stress this. You shouldn't have to pull in RxJS to get observable because there's a 7-year-old proposal languishing in the TC39 right now. But RxJS 8, we want to ship observable in a standalone package. So you don't have to pull in all the operators and all the other stuff. You can just get the observable, use it as you may. You don't need to arm your team with switch map and whatever else they blow things up with. So the previous problem I looked at before, like the question becomes like, what would our previous problem look like in a world with observables? Well, if you're fairly apt with functional programming and observable already existed and it existed in a few places where they said it might exist, it might look a little bit like this, the whole thing. There would probably be a use observed values library that you could pull in. You could probably pipe through, like, get your input reference and say, on this event, here's an observable of that. Debounce it with your own debounce function that you could write in about 10 lines of code. You could switch map it with your very own switch map. You could write yourself or import from a library like RxJS. It would be very simple, and it would be ubiquitous. People would understand this kind of domain-specific language for how things were working on. I'm not saying I recommend this per se, but this is what it could look like. But again, we don't have that, right? If we had the pipeline operator, it might be even cooler, right? I wouldn't even need, but that's not the pipeline operator that the TC39 has given us, by the way. Sad to tell you. All right. I'm kind of ragging on them today. Come on, there we go. All right, so what I really hope you take away from this is async is never as simple as it looks. You could gloss it up with async await or whatever you like, and it makes it a little bit more readable, you think, but there's secret things happening in every single one of those async function calls, and anything could happen when that goes out there. The server could go down, you know, whatever. I want you to consider cancellation paths. Like if someone wants to stop whatever this is from executing, like what are you doing about it in your async code? I want you to consider the error paths as well. That's another thing. I didn't really dive deeply into that, but any await call that you make or any asynchronous thing could error. Like how are you going to communicate that back to the user cleanly? And then I want you to understand your async primitives. Understand promises. Promises have to resolve or reject, right? They're always asynchronous. They perform on a microtask. Look it up. I really want you to explore observable. Not RxJS per se, but the observable primitive type. It's important, and it's so important because if you look out in the world, you will see that there are many things with this observable shape. A lot of them are unfortunately poorly implemented, but they serve their purpose. I really want people to look at this and get active in things like TC39 issues and get active on the internet and teach their friends about asynchronous programming and what observables are and these sorts of things, because the state of what this is right now is a bit painful. There's no reason that I should be the arbiter, or Mladen should be the arbiter of the world's most popular observable implementation. That shouldn't be me at all. It should already be out there. So that's it. Thank you. I hope I didn't ruin your day when you go back and look at your code and you're like, oh God, I'm not putting booleans after my awaits. Thank you very much.